Hello students, in this video we'll study exponents chapter, or it is also called as indices. Very important for your higher classes, at the same time for higher algebra or any mathematics you take. So for the first time we'll try to understand what is this. What is an exponent? For example, if m is a positive integer, then it will be written as a to the power of m, where that is written as a into a into a into a, that is m times. Okay, now what is this now here? Positive integer. So m is positive integer here now, and m times. Okay, now look at this problem here. Here the a is called as the base, and here this a is called as the base, and m is called as the power. Okay, so m is called as the power. So these things you should keep in mind. A is the base and m is the power. The plural of index is called as indices. Okay, so now look at this, a to the power of 10. So here a is the base. Okay, so up to 10 times I'm going to write this multiplication into 10 times. So here a 10 times is written. So a is the base and 10 is the power. Now here it is 5 to the power of 3. 5 is the base and 3 is the power. So I'm going to multiply 5 3 times. So 5 into 5 into 5. So this is how the operations are carried out. Here m is the base and 4 is the power. So m is written 4 times into multiplication. Okay, next. Square and square roots. Let us understand. If I ask you, this is the number 16. What is the square root of 16? The answer would be 4. Okay, so this can also be written as 16 can also be written as 4 into 4, or 16 can also be written as 4 to the power of 2. So 4 is the base and 2 is the power. So for 16, this is the answer. 16 is the square of 4, and in the other way you can also say that 4 is the square root of 16. Okay, 4 is the square root of 16. Now how to represent it? You can see the symbol coming up here. So root 16 is equal to 4, which can also be written as 16 to the power of 1 by 2. So root, here square root is written as 1 by 2. So 16 to the power of 1 by 2 is equal to 4. So 16 to the power of 1 by 2 is equal to root 16. Okay, so now 16 to the power of 1 by 2, here 16 is the base and 1 by 2 is the power, or it is also called as the index. Okay, fine. Next, let us understand cube and cube roots. We have 8. If I ask you what is the square root of 8, you can say answer is 2. Okay, and it is also written as 2 into 2 into this is cube root, so 2 into 2 into 2. So now this is written as 8 is equal to 2 to the power of 3. So now I will write it as 8 is cube of 2. In the other way round, I can also say that 2 is cube root of 8. Okay, 2 is cube root of 8. It's not 4 there, it's wrongly typed there. So this is written as like this, cube root of 8 is equal to 2, which can also be written as 8 to the power of 1 by 3. It's not 1 by 2, it is 1 by 3. Okay, so 8 to the power of 1 by 3 is equal to 2, or it is also written as cube root of 8. You can see the symbol there. Okay, so here 8 is the base and 1 by 3 is the power. Okay, it is also called as the index. Now rules of indices, very important. You can take down this in your notebook. The first rule here, a to the power of m into a to the power of n is equal to a to the power of m plus n. That means if you see two base common and the powers you have, and they are in multiplication, you have to add. Next, a to the power of m divided by a to the power of n is equal to a to the power of m minus n. When you see two base equal and they are in division, you have to subtract the power. Next, a to the power of m bracket n, you have to multiply a to the power of m into n. Next, a into b to the power of m, this can also be separated and written as a to the power of m into b to the power of m. Next, a divided by b to the power of m can also be written as a to the power of m divided by b to the power of m. Next, a to the power of minus m, anything to the power of minus m, if I want to write it in positive, I will take it as 1 by a to the power of m. Very important. This last, the number 6, the formula is very important. A to the power of minus m is equal to 1 by a to the power of m. The 7th one, a to the power of 0 is always equal to 1. That means anything to the power of 0 is equal to 1. If I say 5 to the power of 0, answer is 1. If I ask you 10 to the power of 0, answer is 1. 100 to the power of 0, answer is 1. You have to remember this. So the first basic formulas is given here. Okay, now some basis law, product law. a to the power of m into a to the power of n is equal to a to the power of m plus n. So the bases are same here. So when the bases are same and if there is a product, I am going to add the powers. So now look at the example. 3 to the power of 7 into 3 to the power of 4. Here the bases are same. Okay, 3 and 3, the bases are same. So, and here there is a product in the center. So I am going to add the powers, that is 7 plus 4 gives me 11. So the answer is 3 to the power of 11. Now in the second problem, I have 2 to the power of 6 into 2 to the power of 2. Now you see the bases here. Okay, the base is same 2 and 2 and it is product. So I am going to add the powers, that is 6 plus 2 gives me 2 to the power of 8. Next you have quotient law, that is division. If a to the power of m divided by a to the power of n is equal to, formula is a to the power of m minus n. If you have two bases equal and in between you have division here, so you are going to subtract the powers. Okay, so now here you have bases, that is 3 and 3 and power 7 and 4. So you are going to subtract that. So you are going to write 3 to the power of 7 minus 4. The answer is 3 to the power of 3. Let us see the next example. Here a is a base and powers are 3 and 5, but it is in division, so I am going to subtract it. 3 minus 5 gives me a to the power of minus 2. Okay, next. Problems. Let us directly go and solve the problems now. The first question is 3 to the power of minus 2. Now I know this formula, 3 to the power of minus 2. This formula we have seen, a to the power of minus m is equal to 1 by a to the power of m. So first of all, I will write this as 1 by 3 to the power of 2. Now you know 3 square is 9. So answer is 1 by 9. Okay, so I can write it as like this also, 1 by 9. Okay, next. Minus 4 to the power of minus 2. Once again, this is the question. I am using this formula, a to the power of minus m is equal to 1 by a to the power of m. So now here what happens, 1 divided by minus 4 to the power of 2. Many of the time students do mistakes by taking the forgetting the minus sign, so always take it in the denominator. Okay, so now this is what happens, 1 by minus 4 into minus 4. Okay, so I get minus 4 into minus 4 is 16. So the answer is 1 by 16. Next, 1 by 2 to the power of minus 5. So this is interesting. Look at this now. I know this formula, a to the power of minus m is equal to 1 by a to the power of m. So what do? I directly write 1 divided by 1 by 2 to the power of 5. Okay, so now what happens? This can also be written as 1 by 2 into 5 times. So I'm going to multiply this how many times? I'm going to multiply this 5 times. Okay, total 5 times. And now what happens? This I'm going to solve. So I get 1 by 32. And we very well know what happens to this number 32. It goes to the numerator. So you have to take the reciprocal of the denominator. So the answer is 32. Okay, so this is the answer. Next. Simplify and express the result in power notation with positive exponent. Okay, so now here you have the same base and there is a division. So here I have to use this formula, a to the power of m divided by a to the power of n is equal to a to the power of m minus n. Okay, so I'm going to subtract this. Minus 4 to the power of 5 minus 8 gives me minus 3. And this minus 3 I'm going to use a second formula here, that is a to the power of minus m is equal to 1 by a to the power of m. So what happens here? 1 divided by minus 4 to the power of 3. Now I am going to multiply the denominator 3 times. Okay, or here the question stops us by telling that you have to write the power in the positive exponent. So we can stop here. Okay, next question. 1 by 2 to the power of 1 divided by 2 to the power of 3 to the power of 2. Very interesting question. Look at this now. Now I am going to use this property. A by b to the power of m can be separately written as a to the power of m divided by b to the power of m. Okay, so here what happens? 1 square divided by 2 cube and bracket square. Here I am going to use another formula, okay, that I know. A to the power of m to the power of n gives, I'm going to multiply, it becomes 6. So the final answer is 1 divided by 2 to the power of 6 because I want the powers in the positive. So we can stop here and we can move forward. Next, minus 3 to the power of 4 into 5 by 3 to the power of 4. Okay, so minus 3 to the power of 4 into 5 to the power of 5 by 3 to the power of 4. I can write it like this, minus 3 to the power, minus 3 into 5 by 3, 4 is common, so I can take the power as common. Now I can cancel 3 and 3. I get minus 1 into 5 to the power of 4. Now if I take this 4 outside, okay, I can also write minus 1 to the power of 4 and 5 to the power of 4. So minus 1 4 times gives me positive 1 and 5 to the power of 4 as it is. So the final answer is 5 to the power of 4. This is the final answer. Next, 3 to the power of minus 7 divided by 3 to the power of minus 10 into bracket into 3 to the power of minus 5. So here we have the first division. First we have to solve the bracket. Okay, so here you have a to the power of m division form. So you are going to subtract. So what happens here? 7 minus 7 of minus 10, that gives me minus 7 of plus 10, that gives me plus 3. Okay, this gives me like this, 3 to the power of 3 into 3 to the power of minus 5. Now I am going to use another property, that is product property, and I get m plus n, that is 3 minus 5 gives me minus 2. Now I am going to use another property, that is a to the power of minus m. You have to write in positive because the question is demanding write the powers in the positive exponent. So 1 by 3 square. So answer is 1 by 3 square. Next, 2 to the power of minus 3 into minus 7 to the power of minus 3. When you solve this, you get the answers as taking the powers as common. So 2 into minus 7 to the power of minus 3, you get minus 14 to the power of minus 3, or you can directly write 1 divided by minus 14 to the power of 3. That's it. You can stop it here. Next, find the value of. You have to find the value of this. Simplify. So the first thing, if you see here, 3 to the power of 0, you know anything to the power of 0 is 1. Okay, so what happens here? The first value will be equal to 1, and this is 4 to the power of minus 1. Can I take to the denominator? I can write it as 1 by 4 and bracket into 2 square. So now first solving the bracket, I get the, if I cross multiply and if I take the LCM method, okay, I get the answer as 5 by 4 into 4. So 4 and 4 gets cancelled. I get the answer as 5. So I have simplified and I got the answer as 5. Next, let us try to solve the bracket first. Now it is 1 by using the property product rule. The powers are same, so I can take the base 2 into 4 into to the power of minus 2 and divide by 2 to the power of minus 2. So this becomes 2 square to the power of minus 2. Okay, so this becomes 3 divided by 2 to the power of, so minus 3 divided by minus 2. So when I use the other property, using the division property, you get 2 to the power of minus 3 plus 2. Okay, you get 2 to the power of minus 3 plus 2. Finally 2 to the power of minus 1. And I want the powers in the positive exponent, so I can also write this number as 1 by 2, or the answer is half. Okay, the answer is half, 1 by 2. Okay, next, moving ahead. Now you have the fractions. Now you can look at this question properly. 1 by 2 to the power of minus 2, 1 by 3 to the power of minus 2, and 1 by 4 to the power of minus 2. If you take the reciprocals of each and every fraction, it becomes positive. So I can write the first number as 2 to the power of 2. Okay, 2 to the power of minus 1 to the power of minus 2, 3 to the power of minus 1 to the power of minus 2, and 4 to the power of minus 1 to the power of minus 2. Now if you just multiply the values, minus 1 into 2, okay, if you do like this, okay, then you have 3 into minus 1 into minus 2, again minus 1 into minus 2, you get all positive values. You get 2 square plus 3 square plus 4 square. So what happens if you add all these values, that is 4 plus 9 plus 16, you get 29. Okay, so this is the answer. Okay, next, moving forward. Now look at this. Fourth question is so easy. In the bracket you have 3 to the power of minus 1 plus 4 to the power of minus 1 plus 5 to the power of minus 1 whole bracket to the power of 0. Now no need to solve the values inside the bracket, because outside the bracket something is to the power, that is 0. We all know anything to the power of 0 is 1. So directly you can write the value as 1. Okay, next. Minus 2 by 3 to the power of minus 2, and we are going to solve this now. First multiply the powers here. So you get minus 2 by 3 bracket to the power of minus 2 into 2, you get minus 4. So now I am going to take the reciprocals. I get 3 by 2. Okay, I get 3 by 2 and minus sign continues. It is equal to 4. Now if I split this term, so this can also be written as minus 3 multiplying 4 times gives me 81 and 2 4 times gives me 16. So I can write it as 81 by 16. So this is the answer. Okay, next question. 8 to the power of minus 1 into 5 to the power of 3 divided by 2 to the power of minus 4. So if I take this, 8 can be written as 2 to the power of 3 to the power of minus 1 into 5 by 5 to the power of 3. Okay, so first let me take it as a multiplied values here. Powers I'm going to multiply. So you get minus 3. Then you have 2 to the power of minus 4. Now if you see these two bases are same, okay, base 2 is same and the powers are different and it is in a division form, so I have to subtract it. So when I try to subtract it, I get 2 to the power of minus 3 plus 4 into 5 cube. So I get 2 to the power of 1 into 125. 5 cube is nothing but 125. Twice of 125 gives me value 250. The answer is 250. Got it? Fine. Next, moving ahead, inside the bracket, I'm going to solve that first. 5 to the power of minus 1 into 2 to the power of minus 1 into outside the bracket, you have 6 to the power of minus 1. So first, let us try to solve inside the bracket. You have 1 by 5 into 1 by 2, okay, into 1 by 6. So now I'm going to multiply this. You get 1 by 10 into 1 by 6. So finally, if you multiply, you get the answer as 1 by 60. This is the answer. Next, find the value of m for which 5 to the power of m divided by 5 to the power of minus 3 is equal to 5 to the power of 5. So what happens here? 5 to the power of m divided by 5 to the power of minus 3 is equal to 5. So here I can write this as 5 to the power of m minus of minus 3 is equal to 5 to the power of 5. So this becomes 5 to the power of m plus 3 is equal to 5. Now you can see the bases are same, 5 and 5 is same, so the power will also be equal. Comparing the exponents from the both side, we get m plus 3 is equal to 5. When 3 goes to the right hand side, you get 5 minus 3, so the answer is 2. So the m value is equal to 2. So let us try to understand the next question. Evaluate. So first we have to find the large bracket, okay, then we have to solve the other values. So look at this now. 1 by 3 to the power of minus 1 can simply be written as 3, okay, just taking the reciprocals. Next, 1 by 4 to the power of minus 1 can be written as 4, just simply taking the reciprocal, and out we can take to the power of minus 1. So now what happens? You get 3 minus 4 to the power of minus 1. So you get minus 1 to the power of minus 1. This can also be written as 1 divided by minus 1, or answer is also minus 1. So this is the answer. Minus 1 is the answer. Next, 5 by 8 to the power of minus 7 into 8 by 5 to the power of minus 4. So first I'll just try to take the reciprocals. I'll make it positive, or I can okay, the bases are same on numerator and denominator. I can do in that way also. So if I try to do like this, taking the base and in the division form, so I will go to subtract this now. 5 to the power of minus 7 minus of minus 4 into 8 to the power of minus 4 minus of minus 7. So this becomes 5 to the power of minus 7 plus 4 into 8 to the power of minus 4 plus 7. So the answer is 5 to the power of minus 3, 8 to the power of 3. Okay, so this is the answer. This can also be written as in the positive exponent, that is 8 by 3 to the power of 5 by 3, or you can say the powers are same. You can also take it as 8 by 5 to the power of 3. Okay, so you can take it as the whole number also, 5 by 512 divided by 125. Okay, next question. 25 into t to the power of minus 4 divided by 5 to the power of minus 3 into 10 into t to the power of minus 8. So here what happens, 25 can be written as 5 square into t to the power of minus 4, 5 to the power of minus 3, 5 into 2 into t to the power of minus 8. So here what happens, if I want to subtract it, it becomes 2 minus of minus 3 minus 1 into t minus 4 of minus 8 divided by 2. So when I take the powers subtraction, it becomes 2 plus 3 minus 1 into t to the power of minus 4 plus 8 divided by 2. So this becomes 5 minus 1 is 4, and this becomes t to the power of 4 divided by 2. So the answer is 5 by 4 is 625 and divided by 2. This is the answer. Next, 3 to the power of minus 5 into 10 to the power of minus 5 into 125 divided by 5 to the power of minus 7 into 6 to the power of minus 5. It's easy. 125 can be written as 5 to the power of 3. Okay, so 10 can be written as 2 into 5 to the power of minus 5. 125 can be written as 5 to the power of 3, and 6 can be written as 2 into 3 to the power of minus 5 bracket. Now I open the bracket, simplify it. I can write it as 2 to the power of minus 5, 5 to the power of minus 5 into 5 to the power of 3 divided by 5 to the power of minus 7. Now here I can open the bracket and split the term. 2 to the power of minus 5, 3 to the power of minus 5. And now I'm going to use the division formula and the product rule, quotient rule and the product rule. So using all those product rule and quotient rule one by one, I get 3 to the power of minus 5, 2 to the power of minus 5 into 5 to the power of minus 2 divided by 5 to the power of minus 7 into 2 to the power of minus 5 into 3 to the power of minus 5. Now I'm going to use the quotient rule, that means subtracting the powers. So here I get 3 to the power of 0, and here again I get 2 to the power of 0, and here I get 5 to the power of minus 2 of minus 7. So here anything to the power of 0 is 1. We know that. We'll solve it in the next step. And now this becomes minus 2 plus 7. So 3 to the power of 0, 2 to the power of 0, and 5 to the power of 5. You get 5 to the power of 5. So anything to the power of 0 is 1. We already know. So I will write it as 1 into 5 to the power of 5. So 5 to the power of 5 gives me 3125. So simplifying this, I get the answer as 3125. Okay. Next exercise. Express the following numbers in the standard form. Now you can see there is after 0 there is point, and after point there are some n number of zeros, and then you have last 85. So in this kind of question, how many numbers are there after decimal point that you have to count? Okay, so we have 13 numbers, and now how to express this? So I can write this as 85 divided by 13 zeros. If we write this in index form, we get it as 85 divided by 10 to the power of 13. Okay, I can write like this. In denominator, I'll be writing 13 zeros, and I can also write 85 divided by 10 to the power of 13. 85 can also be written as 8.5 into 10 to the power of 1. Okay, and this can be written as 10 to the power of 13. Now using the quotient rule, I can also take it to the numerator, and then I can also solve 8.5 into 10 to the power of minus 12. So this can also be written as 8.5 into 10 to the power of minus 12. Okay, fine. Next. So similarly, you can solve this question. After 0, you have to count how many digits are there, and you are going to write the number, that is 942. So you can write 942 divided by 13. So you can say 942 divided by 10 to the power of now we have 14 numbers, so 10 to the power of 14. Now this can also be written as 9.42 into 10 to the power of 2, because after 2 digit you are putting point, so it is 10 square, and down you have 10 to the power of 14. Now using the quotient rule, you can take 10 to the power of minus 14, and now using the product rule, you can also write it as 9.42 into 10 to the power of 2 minus 14, that is minus of 14, that becomes minus 12. So this is the answer. Next. Now there is no points, but you can see some number, that is 602, and after 602 you have n number of zeros. You have to count this n number of zeros, and you have to first take it into the power of 10. So this can also be written as 602 into this. Okay, so now what happens? You have to count how many zeros are there. We have 13 zeros. Okay, so we write it in the index form. So 602 into 10 to the power of 13. So this 602 can also be written as 6.02 into 10 to the power of 2, because we are taking point after 2 digit. Now here you can see 10 to the power of 13. Now this is a product rule. You can take the base common, that is 10 and 10, and you can add the powers. So this becomes 2 plus 13. That is, the final answer is 6.02 into 10 to the power of 15. I hope you understood this. Okay, next. Same thing, after point you have to count how many digits are there, and you can take this as 837 divided by that many number of zeros, and you can take 10 to the power of 11 here now, and now you can write 8.37 as 8.37 into 10 to the power of 2, correct? Okay, now this 10 to the power of 11 goes to the numerator, it becomes 10 to the power of minus 11. And now using the product rule, you have to subtract. So when you subtract it, it gets 10 to the power of minus 9. Okay. So this is what happens. Now you have to take 3186 and count the number of zeros. So that many zeros will be to the power of 10. And now if you want to write in the value of 3.186, okay, so this can be written as 10 to the power of 7, and now this is 3.186. Now I am writing 10 to the power of 3 because after point we have 3 digits, and then as usual this will be 10 to the power of 7. Now the base is same, 10 and 10, the power is 3 and 7, so you are going to add as the product rule. So 3 plus 7, this becomes 3.186 10 to the power of 10. Okay, so now this is what happens. Now try to express the following numbers in an usual form. 3.02 into 10 to the power of minus 6. 3.02 divided by 10 to the power of 6. This can be written into this form. Okay, I'm writing the exponent in the like positive form. Now what happens? 3.02, you have to see how many zeros we have. We have 6 zeros. So after point you have to put 6 zeros, and that means the 302 number should also be included. Okay, this is the answer. Now next, 4.5 into 10 to the power of 4. So now here what happens? You have to put that many number of zeros after 45. So 4.5 can be written as 4 into 10 by 10, or 45 by 10, it can be written as 45 by 10, and this is 10 to the power of 4. That means 4 zeros comes here, 1 0 and 1 0 gets cancelled. So now 45 into 1000 gives me 45,000. So the answer is 45,000. Okay, next, 3 into 10 to the power of minus 8. So if I write it in a positive way, okay, so this becomes 10 to the power of 8, and that many zeros after point, that many zeros I'm going to add, and 3 will be included. Next, 1.0001 into 10 to the power of 9. Okay, so here I'm going to write 1000. Okay, and 10 to the power of 9 will be here. So we have 10 to the power of 4 down. Okay, so that many zeros will be cancelled, and we have 10 to the power of 5 here. So the final answer is 1.0001, again 5 zeros. Okay, next, 5.8 into 10 to the power of 12. Okay, so this is 5.8 can be written as 58 by 10. Okay, or it is 58 by 10 into 10 to the power of 12. So you cancelling 1 zeros, I get 58 into 10 to the power of 11, or I have to put 11 zeros in front of 58. Next, 3.61492 into 10 to the power of 6. Okay, so here I can also write this number as 361492 divided by 5 zeros, and cancelling 10 to the power of 6. So we are going to cancel 5 zeros and 5 0. It's simple. It becomes 36192 into 10. That's it. This is the answer. Next, express the number appearing in the following statements in the standard form. 1 micron is equal to 1 divided by, you have some number. So here we have to count how many number of zeros we have. So first thing, you have to count how many zeros. You have 10 to the power of 6 zeros. Now this 10 to the power of 6, when it goes to the numerator, it becomes 10 to the power of minus 6. So this is the answer. So 1 micron will have 10 to the power of minus 6 m. Okay, this is the value. Next, charge of an electron is 0.000. So you have to count how many digits are there after the point. So that many zeros you are going to write. Okay, so you are going to write the number 16 here, and that many zeros down. So after counting the number of zeros, you will find it out. It is 10 to the power of 20. So now 16 will be as it is, or you can take it as 1.6 into 10 to the power of 1, and this is 20 to the power of 20. So when you subtract the powers of 10, you get 1 minus 20, that is minus 19. So answer is 1.6 into 10 to the power of minus 19. This is the charge of an electron. In physics, we will be using these values for solving the problems. Next, size of a bacteria is 0. Some number is given. You have to count the number of zeros. That means 5 divided by, you have to write that many zeros, and you have 5 divided by 10 to the power of 7. This can, if the 10 to the power of 7 goes to the numerator, this will also be 10 to the power of minus 7. Okay, next, size of a plant cell is 0. Some number is given. Count the number of digits after the point. Write down that number, that is 1275, divided by that many zeros down. And now you can take 1.275. So if you take 1.275, so after digits, Okay, you after digits you have 3, that is after point you have 275, that is 3 digits. So you have to take 1.275 into 10 to the power of 3 divided by 10 to the power of 8. So now this becomes 1.275. Okay, this is minus 5. So this is the answer, 1.275 into 10 to the power of minus 5. Next, thickness, if a thick paper is 0.07 mm, so now you have to take 7 and count how many digits are there after point. So you have 7 divided by 100, so the answer is 7 divided by 10 to the power of 2. So if the 10 to the power of 2 goes up to the numerator, it becomes minus 2. So answer is 7 into 10 to the power of minus 2 mm. Okay, fine. So in a stack there are 5 books, each of thickness 20 mm, and 5 paper sheets, each of thickness 0.016 mm. What is the total thickness of the stack? So here thickness of one book is 20 mm. Okay, so here what happens, thickness of 5 books will be 20 into 5, that gives me 100 mm. So now what happens, here they have given thickness of a sheet, that is 0.016 mm, that is thickness of 5 paper sheets each of thickness. Okay, so this is the thickness of one paper. So for 100 mm what happens, I have to calculate thickness of 5 sheets will be 5 into 0.016 mm. Okay, so the answer will be 0.080 mm. But in question they are asking what is the total thickness. So total thickness will be 100 mm into 0.08. Okay, sorry, it is plus. So the answer is 100.08 mm. This is the thickness. Okay, so simple. First you have to calculate the total number of books, that is 5 books. How many pages will be there, how many sheets will be there, and after that you have to find the thickness of each total sheets. So this is the answer, 100.08 into 10 to the power of 2 mm. Next, express each of the following as a power of rational numbers with positive exponent. So 1 by 4 to the power of minus 3 can be written as 4 to the power of 3. So directly you can write 4 to the power of 3, that is 64. Next, minus 1 to the 1 by 4 to the power of minus 5 into minus 1 to the power by 4 to the power of minus 7. You can just take the reciprocal, you get 4 to the power of 5 and you get 4 to the power of 7. So now you have to add this 2. So what happens here, 4 to the power of 5 plus 4 to the power of 5 plus 7 gives me 12. So answer is 4 to the power of 12. Okay, next, evaluate. First we have to solve the brackets, then we have to solve the division thing. Okay, so here 4 to the power of minus 1 can be written as 1 by 4 and 8 to the power of minus 1 can be written as 1 by 8, and this can be written as reciprocal, that is 3 by 2. Okay, this can also be written as 3 by 2. Now solving the bracket, taking the LCM method, you get 2 plus 1 divided by 8, this is 3 by 2. Okay, now what happens, 3 by 8 divided by 3 by 2. Okay, this division can also be taken as multiplication here. Okay, so if I write multiplication sign, the number 3 by 2 becomes 2 by 3. Now 3 and 3 gets cancelled, 2 and 8 gets cancelled, final answer is 1 by 4. 1 by 4 is the answer. Next, in bracket we have 6 to the power of minus 1 minus 8 to the power of minus 1. Okay, like this. So first I'm going to solve the bracket. This can be written as 1 by 6. Next can be written as 1 by 8. Next, plus sign, you have to take 1 by 2 minus 1 by 3 to the power of minus 1. Now first try to solve the bracket taking the LCM method. Okay, so when I take the LCM method, here I have 1 by 24, okay, to the power of minus 1, and here I have, if I take the LCM, here I have 1 by 6 to the power of minus 1. Now taking the reciprocals, that is, this can be written as 24 and this can be written as 6. So 24 plus 6 gives me 30. So the final answer is 30. Okay, I hope you people are finding it easy. With practice, you can do it very faster. Next, you can see the big bracket here now. This can be written as 3 to the power of 3. Okay, or second one can be written as 2 to the power of 3. And then you have division, and this can be written as 4 to the power of 3. Now solving the bracket, 3 to the power of 3 is nothing but 27, and this is 8. Okay, so 27 minus 8 divided by 64. So 27 minus 8 gives me 19. So 19 divided by 64, you have to tell the answer for this, that is 19 by 4. Ho gaya? Next, Write in the standard form 4 divided by 1 lakh. So here you have 4 divided by 10 to the power of 5. So this can also be written as 10 to the power of minus 5. Next, express the following number in usual form, 3.52 into 10 to the power of 5. So after point you have 2 digits, you have to subtract 2 digit from here, that is 352 by 100. So you get 352,000, that is okay. You have just subtracted 2 zeros from this. Next, 4.5 10 to the power of 4. Now you have to subtract 1 zero, so it gets sorry, the question, next question is 7.504 into 10 to the power of minus 4. Now you have to divide 754 divided by 100 into 10 to the power of minus 4. So final answer is 0.000754. Next, 3 into 10 to the power of minus 5. So you can write 3 divided by 10 to the power of 5. Okay, and that many zeros after the point. So you can write 0.00003. Okay, that's it. You have to count the number of zeros and you have to write the number. Next, 216, count the number of zeros and you can just take to the power. So 216, this is equal to 10 to the power of 6. 216 can also be written as 2.16 into 10 to the power of 2 into 10 to the power of 6. This becomes 10 to the power of 8. So 2.16 into 10 to the power of 8. Next, 0.000529 into 10 to the power of 4. So you have to count after the point how many digits you have. So this can be written as 529 divided by 10 to the power of 7 into 10 to the power of 4. Using the quotient rule, you have to subtract 7 minus 4. 7 minus 4 gives me 3. And 529 can be written as 5.29 into 10 to the power of 2. So the final answer is 5.29 into 10 to the power of 2 into 10 to the power of 3. That means you are going to add it. Okay, so the final answer is 5.29 into 10 to the power of minus 1. Okay, friends. So I hope you understood the basics of the these chapters, that is indices and exponent. So you require more practice. If you want more questions, you can ask me. I will give you via WhatsApp. Thank you. Have a nice day.